Hello friends, welcome back to our channel Elevate Learning Hub. Today our topic is large language models, their importance, training, the future of large language models, the importance of neural network which is being there, computer vision and neural networks, natural language processing and how neural networks works with that, different types of neural networks, deep learning which is being involved at the back end of the neural networks, what are the use cases of deep learning and the difference between deep learning and machine learning. So let's get started. But before that, I would request you to please do subscribe to our channel. All right. So first we'll be talking about that what are large language models. They are very deep learning models that are pre-trained on vast amount of data. The underlying transformer is a set of neural networks that consist of an encoder and decoder, which we spoke in the last video of ours, which has self-attention capabilities. And then the encoder and the decoder, they extract the meaning from the sequence of the text and understand the relationship between the words and the phrases which is being talked about. From a transformer LLM perspective, they are capable of unsupervised training. Although a more precise explanation is that the transformer can perform self-learning, and it is through this process that transformers learn to understand basic grammar, language, and knowledge. Unlike earlier recurrent neural networks that sequentially process inputs, transformer process entire sequences in parallel. And this allowed data scientists to use GPU for training transformer-based large LLM machine language models, and it significantly reduced the training time overall. Transformer neural network architecture allows the use of very large models, often with hundreds of billions of parameters, and such large scale model can ingest massive amount of data, often from the internet but also from the sources such as the Common Crawl, which comprise more than 50 billion web pages, and Wikipedia, which has approximately 57 billion pages overall. Now, why are large language models important? Large language models are incredibly flexible. In today's world, one model can perform completely different tasks such as answering questions, summarizing documents, translating languages, and even completing sentence. They have come across multiple use cases in the industry, which is of chatbots summarizing the large documents, or writing blogs, or translating different languages which is being required for interpretations. And large language models have the potential to disrupt the complete content creation, the way people now use search engines and virtual assistants. While this is not perfect, but LLMs are demonstrating a remarkable ability to make predictions which are based on relatively small number of prompts or inputs. LLMs can be used for generative AI to produce content based on input prompt in human language. Now we'll be talking about that how copywriting and content creation is being happening. Apart from GPT-3 and ChatGPT, Llama 2, Claude, and other models, they write the original copy, and even there are certain style and voice enhancement models as well, like World's A AI-21 World Spice, which suggests changes to the original sentence to improve the style and the voice as well. So it limits your capabilities that what is being written by AI, and then you can go on enhancing that style and can do the voice enhancements as well on top of it. How the generated content now is in a position that it can, the knowledge base can answer your queries. Often referred to as knowledge intensive natural language processing, the technique refers to as LLMs can now answer specific questions from information. And this really helps. An example is the ability that AI-21 Studio Playground can answer general questions, so which are knowledge questions. Moving forward, we have also seen that LLMs have the proficiency to generate the code from natural language prompts. For example, If you give prompt to Code Whisper, which is Amazon Code Whisper, or OpenAI Codex, which is there in GitHub Copilot, which can code in, and these tools can code in Python, JavaScript, Ruby, and several other programming languages. Other coding applications such as SQL queries, writing shell commands, and website design could also be done. So, if you would see, we have talked about 3 use cases so far: code generation, your content writing, and even style, improving the style on top of it is something which we can expect from the LLMs nowadays. Now we are moving forward with the text classification. Using clustering, the LLMs can classify text with similar meanings or sentiments. It includes measuring customer sentiments, determining the relationship between the text, and document search. Text generation, which is similar to the code generation, text generation can complete incomplete sentences and can write product documentation as well. Or like Alexa, they can go on creating children stories as well. And even not only children's stories, you can go on writing your blogs and many more with that. How are these large language models trained? Transformer-based neural networks are very large. These neural networks contain multiple nodes and layers. Each node in a layer has contained many such connections to all node in the subsequent layer, which has a weight and a biases. Now, these weights and biases along with the embeddings are known as model parameters. And these large transformer based neural networks can have billions and billions of such parameters. So, the size of model is generally determined by the empirical relationship between the model size and the number of parameters and size of the training data. And this training is then performed using large corpus of the high quality data. During the training, models iteratively adjust these parameters values until the model correctly predicts the next token from a previous sequence of input tokens. It does that through the self-learning techniques, which teach the model to adjust parameters to maximize the likelihood of the next token in the training example. Once trained, these LLMs can be readily adapted to perform multiple tasks using small sets of supervised data and can even be trained with the fine tuning as well. What are the learning models in these LLMs? So there are 3 common learning models. We call them at zero shot, few shot, and fine tuning. What do you understand by zero shot learning? Based on the LLMs can respond to broad range of requests without any explicit learning. Often these prompts gives you the accurate results. So this is completely zero shot learning, that without any training they'll be able to answer your query. What is there in few shot learning? By providing a few relevant training example, base models perform significantly improve on a specific area. And what is fine tuning? This is an extensive of few shot learning in that data scientists train the base model to adjust its parameters with the additional data relevant to the specific application. So generally, as a part of when we do these B2B LLMs, we generally do these fine tuning properly because they have to respond to specific queries. But when it comes to English language or basic knowledge questions, the zero shot learnings work. What are the future of large language models? As an introduction of the large language models like ChatGPT, Claude 2, Llama 2 that can answer questions and generate text points to exciting possibilities in the future. Slowly but surely, LLMs are moving closer to human-like performance. The immediate success of these LLMs demonstrate a keen interest in robotic type LLMs that illuminate and in some contexts outperform the human brain. There are some thoughts on the future of LLMs. Increased capabilities, as impressive as they are, the current level of technology is not perfect and LLMs are not infallible. However, new releases have improved accuracy and enhanced the capabilities the developer can learn and improve their performance while reducing biases and eliminate the incorrect answers. Audiovisual training. While developers train most LLMs using text, some have started training these models using video and audio input as well. This form of training actually lead to faster model development and open up new possibilities in terms of using LLMs for autonomous vehicles and many more. Moving forward, from the workplace transformation perspective, LLMs are a disruptive factor. This will change the workplace. LLMs will likely reduce the monotonous and repetitive tasks in the same way that robotics did for repetitive manufacturing tasks some eras back. Possibilities include that repetitive clerical tasks as well, or even the customer service chatbots and simple automated copywriting. All these are going to be taken away by the conversational AI, and LLMs will undoubtedly improve the performance of automated virtual assistants like Alexa, Google Assistant, Siri, and many more. This will be better to interpret user intent and respond to the specific command that is being talked about. Now we'll be focusing on that what is neural network, which is behind this. A neural network is a method in artificial intelligence that teaches computer to process its data in a way that is being inspired by the human brain. It is a type of machine learning process called deep learning that uses interconnected nodes or neuron in layered structure that resembles a human brain. It creates an adaptive system that computer uses to learn from their mistakes and improve continuously. Thus, artificial neural network attempt to solve complicated problems like summarizing documents, recognizing faces with greater accuracy. We'll be focusing that why neural networks are important. It helps computers make intelligent decisions with limited human assistance, and this is because they can learn and model the relationship between the input and the output data that are nonlinear and complex as well. For instance, they can do following tasks: make generalization and interference. Neural networks can comprehend unstructured data and can make general observations without explicit training. For instance, they can recognize the two different input sentences that have the similar meaning. Let's take an example. Can you tell me how to make the payment, or how can I transfer the money to someone? It's a neural network would know that both these sentences mean the same thing, or it would be able to broadly recognize the place and the broader messaging around this. So distinguishing between the names, places, personal names, identifying the similar meanings between different sentences is something which it makes very easy. What are these neural networks used for? Neural networks have several use cases across many industries, such as medical diagnosis of medical image classification, targeted marketing by social network filtering, and behavioral data analysis. Not even that, financial prediction by processing historical data of the financial instruments, your energy demand forecasting, your process and quality control, chemical compound identification are few areas which we can easily solve with the neural networks. Now we'll be focusing for some time onto the computer vision and neural networks. How computer vision has provided the ability of computers to extract the information and insights from the images and videos. And with this neural network, computers can distinguish now and recognize these images similar to humans. Human computer vision has several applications such as your visual recognition, which is being used in self-driving cars, and they can recognize the roads and signs just like human. Content moderation to automatically remove unsafe or inappropriate content from image and video archives. Facial recognition. It can identify faces and recognize attributes like open eyes, glasses, and facial hair. And even image labeling to identify brand logos, clothing, safety gears, and many other such detailing. Now talking about not even image recognition, the speech recognition is something which neural network can analyze human speech and vary speech pattern, pitch, tone, language, and accent. And with this virtual assistants like Amazon, Alexa, and automatic transcription software uses speech recognition to do tasks like that it can now assist call center agents to automatically classify the calls, convert clinical conversation into documentation in real time. It can actually give subtitle videos and meeting recording for wider content reach. So now, as a part of a meeting, if you're not there now, you can record that meeting, and your speech to text has completely enabled the people that post the meeting. They can see, they can go back to the video analyzing that what have they missed out and where their names were being specifically called out and their actionables which were being pending on them. Now we'll be moving on to understand the natural language processing, the ability to process the natural human created text. Neural networks help computer gather those insights and meanings from the text data and documents. Natural language processing has several use cases, including functions, automated virtual agents and chatbot, automated organization and classifications of written data, business intelligence analysis of long-form documents like emails and forms, and indexing of key phrases like your indicate sentiment like positive, negative, or on social media, document summarization, the article generation on a given topic, and many more. Moving forward, we'll be focusing on that what neural networks can track user activity to develop personalized recommendation, and they can also analyze all user behavior and discover the new product or services that interest a specific user. For example, this is a real case study for a Correlate, which is a startup, and it helps the brand convert social media posts into sales. Brand uses the intelligent product tagging service to automate the collection and curation of user generation social content, and it uses the neural network to find automatically the recommended products, and consumer do not have to hunt through the online catalog to find a specific product as per their need. Isn't it that was a great part from the neural networks to give recommendations? Now moving forward, we'll be talking about that how neural networks work at the back end. This is more like a human brain. The inspiration behind neural network architecture is just like human brain cells called neurons, which form a complex, highly interconnected network and send electric signal to each other to process information. Similarly, an artificial neural network is made up of artificial neurons that work together to solve a problem, and artificial neurons are software modules called nodes, and artificial neural networks are software programs and the algorithms at their core. So simple neural network architecture, a basic neural network has interconnected artificial neurons in three layers, which is the input layer, where the information from outside world enters the artificial neural network. Input node processes the data and categorizes it and pass it to the next layer. Moving forward is the hidden layer, where hidden layer takes their input from the input layer, and another hidden layer, artificial neural network, can have a large number of hidden layers. Each hidden layer analyzes this and then generates the output layer. Output layer gives the final result to the data processing by artificial neural network. It can have a single or multi-node. For instance, if you have binary, which is yes or no classification problem, the output layer would have one output node, which is the result. It is 1 or 0. But it can have a multi-classification problem as well, which the output layer might consist of one or more nodes. Moving forward, we'll be talking about that how deep neural network architecture works. They have the similar hidden layers with millions of artificial neurons linked together. A number called weight represents the connection between one or another, and the weight is a positive number of one node which excites another from negative if one node suppresses the other. Nodes with higher weight values have more influence onto the other nodes. Theoretically, deep neural networks can map any input type to another output type. So, in need of more trainings as compared to other machine learning models, they need millions of examples to train rather than perhaps the hundred and thousands and make a simpler network which is being required. Now we'll be talking about that what are the different types of neural networks. Artificial neural networks can be categorized by how the data flows from input node to the output node. Both these examples, feed-forward neural networks is basically which flows the data in one direction from one input data to the output node. Every node in one layer is connected to the every node in the second layer, and the feed-forward node uses the feedback process to improve predictions over time. And backward backpropagation algorithms, it runs in an artificial neural network where it is learning continuously by using the corrective feedbacks and loops to improve their predictive analytics. In simple terms, you can think of the data flowing from the input node to the output node through many different paths in a neural network. Only one path is correct and the other path maps the input to the correct output. To find this path, the neural network uses a feedback loop which works as follows: that each node makes a guess about the next node in the path and it checks the guesses that is correct, and then nodes assign a higher value to the path that leads to more correct guesses and lower value to the nodes that leads to incorrect guesses. And then for the next data point, the nodes makes a new prediction using the higher weight paths and then repeats the step. The last one is convolutional neural networks. The hidden layer in the convolutional neural networks performs specific mathematical functions like summarizing, filtering, and they are very useful for image classifications because they can extract relevant features from images that are useful for image recognition. The new form is easier to process without losing features, and it's very crucial for making good prediction. Each hidden layer extract processes different image features like edges, colors, and the depth. Moving forward, we'll be talking about how to train neural network. Neural network training is the process of teaching a neural pattern to perform the task. Neural network learn by initially processing several large set of unlabeled or labeled data by using these examples. They can then process unknown input more accurately. So supervised learning. In supervised learning, data scientists give artificial neural network the labeled data sets that perform the right answer in advance, and then a deep neural learning model in facial recognition of hundreds of thousands of images recognizes this human face. The neural network slowly builds knowledge from these data sets and provides the right answer in advance itself. Now we'll be talking about what is the deep learning in the context of neural network. Artificial intelligence in the field of computer science, the researchers has given the ability to perform tasks that require human intelligence. Machine learning is an artificial intelligence technique that gives computer access to large data sets and teaches them to learn from that. Machine learning software finds patterns in existing data and applies those patterns onto the new data to make intelligent decisions. Deep learning is a subset of machine learning that uses deep learning networks to process that data. Machine learning versus deep learning. In machine learning, the learning methods require human inputs for the machine to work and sufficiently work well, wherein a data scientist manually determines a set of relevant features that the software must analyze. This limits the software ability, which makes it tedious to create and manage. Whereas, on the other hand, when it comes to deep learning, the data scientists only give the raw data to the software. And then the deep learning networks derives the features by itself and learns more independently. It can analyze the unstructured data like text, documents, and identify which data attributes to prioritize and solve more complex problems. From the importance of the deep learning, AI intelligence attempts to train computers to think and learn as humans do. So, now the deep learning technology drives many AI applications used in everyday products such as digital assistants, voice activated television remotes, fraud detection, and automatic facial recognition. It's also a crucial component for emerging technologies wherein in the world of today we have self-driving cars, we have virtual reality. Deep learning models are computer files that data scientists can now train to perform tasks using the algorithms or a predefined set of steps. Business uses deep learning models to analyze this data and make predictions on various applications. What are the use cases of the deep learning that is being looked out? In automotive, aerospace, manufacturing, electronics, everywhere there are deep examples. Like in automotive, we can talk about there is self-driving cars using deep learning models to automatically detect road signs and pedestrians. In defense and surveillance, we can use deep learning to automatically flag areas of interest in satellite images. In medical advancement, we can have medical image analysis use deep learning to automatically detect cancer cells for medical diagnostics. In factory, we can use deep learning application to automatically detect when person or objects are within unsafe distance from the machine, and you can group these various use cases into broader computer vision, speech recognition, natural language processing, and other recommendation engines part. Now moving forward, how deep learning works. They are the neural networks that are modeled after the human brain. For human brain now, the way it contains millions of interconnected neurons, the same way that works together to learn and process information. Similarly, deep learning neural networks or artificial neural networks are made of layer of artificial neurons inside the computer, and these are called nodes. And these mathematical calculations processes the deep algorithms that solve these nodes for the complex problems. The components of deep neural networks are input layer, the hidden layer, and the output layer. As a part of the input layer, the artificial neural network has several input onto it. The hidden layer processes this information, and then the output layer gives the response after analyzing the problem from several different angles. If you're given an image of an unknown animal, the unknown animal that you have to classify, it compare the animal with known, and then the shape, eyes, ears, legs, patterns, and all that. And animals, then the animal has a cat, the eye, the type of the wild cat, the hidden layer processes this information, and then the output layer gives you the final output with the deep learning models. The output could be in yes or no, or the way we suggested, it could be wide answers based on the question that is being asked for. Now we'll be talking in depth at what is the difference between deep learning and machine learning. As we initially also talked about, that deep learning algorithms emerge in an attempt to make a traditional machine learning technique. Traditional machine learning techniques required significant human brain to train the software. There was a lot of manual effort labeling thousands of animal images, making large language models or machine learning algorithms process those images, test those, and there were a lot of inaccurate results as well. Wherein this process is called supervised learning. In supervised learning, accuracy improves only when you have a broad and sufficient varied data set. For instance, the algorithm might accurately identify black cats but not the white cats because the training data had more images of black cats. So, in the very data set, you need to label more white cats and images to train that. Vis-a-vis, in terms of the deep learning enhances the efficiency of the traditional learning models and it reduces the human effort altogether. What are the benefits of deep learning over machine learning? The deep learning has following benefits: that it efficiently processes the unstructured data. Machine learning methods find unstructured data such as text to process the information. On the other hand, the deep learning method can comprehend unstructured data and it can make general observations without any manual feature which is being there in between. It has a capability of unsupervised learning as well, which is based on the user behavior without any needing to label this data set. Now we'll be talking about what are the benefits of deep learning in the cloud. Running these on the cloud's infrastructure can overcome many challenges. You can train the deep learning algorithm, it can provide you the speed, train deeper, faster models by using clusters of GPUs and CPUs to perform complex mathematical operations, and you can deploy these models to process large amount of data. And from a scalability perspective, with the wide range of on-demand resources available on the cloud, you can access virtually unlimited hardware resources, deep learning models of any size, and these neural networks can take the advantage of those processors anytime. Moving forward, what is the foundation model? The foundation model is trained on massive amount of data and are deep learning neural networks that have changed the way data scientists approach machine learning. From the scratch, the foundation model as a starting point to develop machine learning algorithms and power new applications more efficiently. They have the capabilities of performing wide variety of general tasks such as understanding languages, generating text, and conversation in natural language processing itself. From a unique feature of the foundational model perspective, they have the ability to perform capable of tasks with precision. They can distinguish between traditional machine learning models and then can be the base for specialized applications, and they can evolve with the time which is being required. Oh, what is the importance of foundational modeling? They are poised for significantly change the machine learning cycle altogether. Although it currently costs millions of dollars to develop a foundation model from the scratch, it is faster and cheaper for data scientists to use pre-trained functional models to develop new machine learning algorithms. And these models are the foundational models which has the reasoning capabilities as well to streamline various processes. How these foundational models work: from a generative AI perspective, these models have the complete artificial generative intelligence in themselves, and they generate output from one or more inputs prompt in the form of the human language instructions which is being given to them. Models are based on complex neural networks, which are GANs, and transformers and variational encoders, and each type of these network function differently principle behind how they are similar. For example, for an image generation, the model analyzes the image and creates a very sharper, more clear image. And similarly, the model predicts the next words in the string as well. So these foundational model uses the supervised learning to create labels from the input data, and this feature separates LLMs from the machine learning architecture, which is uses the supervised or unsupervised learnings. So from a capabilities of the foundational model perspective, these models can continue from a data input or prompt during the interface, and this means that you can develop comprehensive outputs with carefully curated prompts. These foundational models can perform large language processing itself, and these models have remarkable capabilities to answer natural questions and write even the short scripts. From the visual comprehension, functional model excel in the computer vision, and they have the capability to have visual comprehension, language processing, and adaptive learning capabilities as well, along with the code generation, and they have speech to text application areas as well. What are the examples of foundational models? Let's focus in. There are large number and size of foundational model in the market which we can see. Here are the prominent lists which we have spoken about. That in 2018 there is BERT, which was the first bidirectional model analyzing complete sequences, then which is being trained on the plain text and Wikipedia of 3.3 billion tokens. Moving forward, we had GPT, which was the generative pre-trained transformer model, which was developed by OpenAI in 2018, and it uses 12-layer transformer decoder with a self-attention mechanism, and it was trained on a corpus dataset of which is 11,000 free novels. And a notable feature of GPT-1 is that it has the ability for zero-shot learning as well. There were many more as well, which we've been talking about: the common crawl set data, Amazon Titan, then stable diffusion, Bloom, and Hugging Face as well. The key features of foundational models is also being we have listed here, so you can have a look onto this. Moving forward, what are the challenges with the foundational models? It require an infrastructure which is high cost. It require a front-end development which requires prompt engineer and fine-tuning to a large extent. It lacks of comprehension, that there is struggle with the context understanding, and then the complete reliability on the answers which it's being providing it. So that's all for today. That Thank you.